Alright, in this video we're going to go over dividing polynomials as well as the remainder and factor theorems. Alright, so dividing polynomials. First let's talk about long division with polynomials. Alright, so what we want to do is we want to take this polynomial, x cubed plus 4x squared minus 5x plus 5, and divide it by x minus 3. So, we set up our long division. X minus 3, draw a little house, put our polynomial below it. Now the fun starts. Alright, how many times will x minus 3 go into x cubed? Well, it won't. So what about x minus 3 into x cubed plus 4x squared? Alright, so just the first two terms. Well, if you notice, if you multiply this by x squared, you get x cubed, and here you get a negative 3x squared. So that means that x minus 3 will go into x cubed plus 4x squared times. Now what you do is you take the x multiplied by x squared, that's x cubed, minus 3 times the x cubed is 3x squared. I'm sorry, times the x squared is 3x squared. And then you subtract. Okay? So this is going to go negative, that's going to go positive, this cancels, this gives us 7x squared. Because remember, we subtracted, so we have to distribute the negative through. So this is negative x cubed, and this is now a plus 3x squared, because we're subtracting this from that. And then you bring down this term, so minus 5x. How many times will this go into there? Well, it'll go in positive x times. I'm sorry, plus 7x times. Because really all you're looking at is this term. You know, what times this is 7x squared? Well, it's a positive 7x. Okay, same thing here. What times this is x cubed? Well, it's a positive x squared. So now x times 7x is 7x squared. Negative 3 times positive 7x is negative 21x. Alright, so now we need to subtract, so that goes to a positive. That cancels. 21x minus 5x is 16x. And then you bring down the plus 5. And you do it again, it's going to be plus 16 because x times 16 is 16x. And then negative 3 times 16 is negative 48. Again, subtract it, so this is going to be negative, that's going to be positive, and this will give us 53. So, our answer is, when we divide this polynomial by x minus 3, it's x squared plus 7x plus 16, remainder 53. Okay? So this is our remainder. Alright, that's our remainder. So, that's how you do polynomial long division. Alright, you set up this is called your divisor, because that's what you're dividing by. Alright, your answer up here is called your quotient. And then what's under the house here is called your dividend. Alright, and then of course what you're left with is your remainder. But that's polynomial long division. All you simply do is x, how many times we go into x cubed? Well, what do we need to multiply by x to get to x cubed? Well, x squared. So x times x squared is x cubed. Negative 3 times x squared is negative 3x squared. Subtract it, so this becomes negative, this becomes positive. This cancels, this becomes 7x squared. What times x is 7x squared? Well, that's a 7x. So you do the multiplication. I'm sorry. Then you bring down the negative 5x down here, you do the multiplication. So x times 7x is 7x squared. Negative 3 times 7x is negative 21x. Subtract it again, this becomes negative, this becomes positive. So negative 5x plus 21 is 16x. What times x is 16x? Well, the answer is 16. So x times 16 is 16x. Again, I forgot to bring down the 5. I'm trying to get this video over quickly, and I'm making mistakes. So we drop down the 5, and then you do your multiplication. So 16x, and then that gives you the 48. Again, subtract it, so negative, positive, 53. That's the remainder. because x won't go into the 53 and there's nothing else to bring down. So we are finished. Okay? Now, I'm going to show you a little easier way to divide the same thing. This is called synthetic division. Synthetic division. Now, this is our divisor. But now what we put out here, this 3 is C. So what we have to do is take our divisor, x minus 3, set it equal to 0. Okay, and then solve. Plus 3, x equals 3. So that means C is 3, because this is x minus C. So that means C is positive 3, so that's why we have a positive 3 out here. If you want to do a little shortcut, this is x minus 3, so this will have to be a positive 3. All right, x minus 3, positive 3. If this had been x plus 3, this would be a negative 3. All right, now, you take the coefficients of all of these terms. Coefficient here is 1. Coefficient here is 4, negative 5, plus 5. Now, if any of these had left out an exponent, you'd have to put a 0 in its place. For example, if this was just x cubed minus 5x plus 5, instead of a 4, we would have had to put a 0, because you have to put the placeholder in. If it's not there, its coefficient is 0, you have to put in the placeholder, or it's not going to work. All right, now, I'm going to try to color code this. Now, with synthetic division, you always bring down your first term, so 1. All right, now, you do 3 times 1. 3 times 1 is 3, so you write that here. And then every time you go down, you're adding. Every time you kind of go at an angle, you're multiplying. So 4 plus 3 is 7. All right. And then again, we're going across here.
Alex Garcia, your ride is late.
So we multiply. 3 times 7 is 21.
Excuse me, Alex Garcia, your ride is waiting.
So now we have to add. Negative 5 plus 21 is 16. And again, come through here and multiply. 3 times, that's an x for multiply. 3 times 16 is 48. And again, you add going down. 48 plus 5 is 53. And again, this last number here is your remainder. Okay, 53 is your remainder. Now, we started with a polynomial of degree 3. So that means our answer is going to be of degree 2. Because your answer is always 1 degree less than what you started with. We started with 3rd degree. This is going to be 2nd degree. And this is simply, this is your highest exponent term. So it's 1x squared plus 7x to the first, or just 7x, plus 16 with a remainder of 53. Okay, you don't really have to write R53, I just did that. Actually, the correct way to write this, including the remainder, would be like this. Okay? So, if you notice, we got the same answer, we got the same exact answer both times. X squared plus 7x plus 16, remainder of 53. So, synthetic division, if you want to learn that, synthetic division is actually easier and quicker to do than polynomial long division. Okay? So if you want to do synthetic division, that is fine. I know some of the problems will have you do polynomial long division, and for the sake of those problems, I do want you to do the long division. But on the tests, I don't think there's going to be any long division on the test. I think it just says divide. So you can pick any method you like. All right? All right, now, remainder theorem. Okay? Remainder theorem. Say we're given the polynomial x cubed minus 4x squared. It's the same thing. Plus 5x plus 3. And we want to use the remainder theorem to find f of 2. All right, we want to use the remainder theorem to find f of 2. So what do? You do synthetic division. We take the 2 and put it out front, draw kind of an elongated L, bring down your coefficients, 1, -4, 5, and 3. And now you simply perform your synthetic division, and whatever your remainder is, that is f of 2. Okay, f of 2 equals whatever the remainder is. So bring this down, 1, 2, add, -2, -4, add, 1, 2, add, 5. So f of 2 for this polynomial is 5, because that's what we got for our remainder theorem. And if you plug it in, you'll get the same thing. F of 2 equals 2 cubed minus 4, 2 squared, plus 5 times 2 plus 3. 8 minus 4 squared, 2 squared is 4 times 4 is 16, plus 10 plus 3. 8 minus 16, this is -8, plus 10 plus 3. 10 minus 8 is 2 plus 3, 5. So you can see we got the same answer both times. So if you have a long polynomial, it may be quicker to just use the remainder theorem to evaluate the polynomial at a specific number. Right? Because remember, when you do the remainder theorem to find a function evaluated at a number, you put that number as is out front and then perform your synthetic division, and your remainder is that function evaluated at that value. Okay, just like we did here. That is all you need to know for remainder theorem. Okay? Now, there's one more thing I want to go over, and that's called the factor theorem. Okay? Factor theorem. It still involves synthetic division. All right, it still involves synthetic division, but say you're given the polynomial 2x cubed minus 3x squared minus 11x plus 6, and we want to know is x minus 3 a factor of that polynomial? All right, so we want to know, is x minus 3 a factor of this polynomial? Well, what do? We do synthetic division. This is x minus 3, so you're going to put a positive 3 out front. Bring down your coefficients. Perform synthetic division. Now, with the factor theorem, if your remainder equals 0, then this is a factor. Okay? If the remainder is 0, this is a factor. Let's give it a shot. 2, 6, 0, 0. How did I get that 0? That's 3, 9. That is -2, -6, 0. Bam. So therefore, 2x cubed minus 3x squared minus 11x plus 6 has x minus 3 as a factor. Okay, this is a 3 here. It's hard to read. And this here is a 9. Okay, since our remainder came out to 0 when we did synthetic division, that means whatever our divisor was, in this case we were dividing by x minus 3, so we put a positive 3 out here. That means that this is a factor because our remainder equals 0. All right? And that is it. So, long division, synthetic division, remainder theorem, and factor theorem. Okay, I know it was a lot of concepts to go over. You can rewatch this video as many times as you want. But make sure you understand the concepts and come to class tomorrow ready to work some problems. See you tomorrow.